Awesome. Welcome, everyone, to the supply chain breakout session, where we're going to go into an in-depth product dive-in, where you're going to be able to get your hands on the application. So if you're not sitting at one of the computers, I'm going to ask that you kind of shuffle around and get close, because this is going to be a hands-on session where you actually get to now go dive into our applications and play around with that. But before we do that, so my name is Justin Kendig. I'm one of our product managers here at C3 AI in the supply chain suite, and I'm joined by my colleague Soumyo, who is also one of the product managers. And so what we're going to talk you through is a little bit today about our roadmap, what we're working on in the supply chain suite, what we're covering, why we chose this particular suite of applications, and how we've gotten to that point, and then where we're going in the future. And then about 10 to 15 minutes in, then we'll go into the hands-on session for, at this point, production schedule optimization. And then at the end, we'll be able to ask questions. But during the hands-on session, it's going to be highly interactive, where you guys can start to get into the software. All right? So our supply chain suite, as you guys have heard, we have the platform that we've been building for over 15 years. Our supply chain suite has evolved with our key partner customers over probably the last 4 to 5 years, where we've identified what are the really high value use cases where artificial intelligence can really drive that value and solve those really hard problems. And so over the years, what we've developed is our demand forecasting application. Notice this doesn't say demand planning. This is really focused on how do I get you the most accurate statistical forecast to drive your planning processes. We have our inventory optimization, where we're going to use stochastic optimization to truly learn from the history and on a weekly basis go update your inventory parameters. So you're continuously evolving into what your safety stocks, your reorder points, your min-max levels, what you should be using in your system instead of letting it just be set and then forget about it. Our production schedule optimization, where we're going to go deeper into today, is there are millions of constraints. There are hundreds of objection functions. There is no way that your schedulers can handle all of this data and get you that truly optimal schedule, because the network is constantly evolving. And so how do you make sure that at any given day when you start your production schedule, that you are now optimized and truly using the best schedule that you possibly can? Our sourcing optimization, this is now a little bit focused, that upstream piece, around your buyers and the buying community. And how do we go identify those cost reduction opportunities on where are you paying too much, where are you paying not enough, and being able to say, hey, you know, as soon as a purchase order is generated, we're going to raise that alert and we're going to say, hey, you need to now pay attention here. And we're using anomaly detection to be able to now go identify some of those opportunities. And then our supply network risk is how do we start to identify and predict when you're going to have issues in your network. And so the ability of when is a purchase order going to be late? When are you going to be late to a customer response? When is your production schedule going to be clear to build? How do you now start to run those models, pull in external information, pull in all your existing internal information, and be able to get out ahead of these issues so you can mitigate them before they become a problem? All of these applications are enabled by sitting on the C3 AI supply chain digital twin that is specifically designed to run machine learning and advanced optimization on it. And so that is our true secret sauce, is that object model that allows us to now go run these capabilities. And all of our applications sit on that, so the ability to now start with one, spin up the next one is very quick because the platform's there. The data starts to be shareable. It's now ready so you can start to use it across the applications. And then as you'll see in our roadmap, where we're using the agentic AI platform, and now what does that start to look like in our applications going forward in the future? So we have been working on this, I said, about 4 to 5 years, really pouring into these applications. And so we have started to deploy with some of the most iconic companies around the world. As you've heard, many different successful deployments. Some of you are sitting in the room. Some of you we talked to, definitely it's been growing, and it's industry agnostic. Is whether you're talking about manufacturing, whether you're talking about retail, supply chains are moving things throughout that. There are slightly different problems that you're solving, but the specific use cases is where we're starting to focus to be able to say, hey, Where can we start? Where can we start driving value? And then how do we expand these capabilities to meet the different needs from everyone? And all of this as we go through is, in order to enable these, we're obviously going to go pull in the data from those traditional data sources, from your ERPs, your sales, your inventory, your purchase orders. Like, those are the common ones that you have to expect. But how do you get those non-traditional sources, your pricing information, your promotions, your CRM data? How do you enhance your forecast to get all the information that's truly driving the signals so that we can now start predicting and learning from what's happening in the past to now predict what is your supply chain going to look like in the future? And then the ability to bring in a lot of the external sources to be able to say, hey, what's that extra information that is really impacting your network? How do you bring that in so that we can now say, is it weather related? Can you pull in external indices? Can you pull in supplier risk elements from other sources? These are the systems that you guys already have, and you're monitoring, your experts are watching these things. How do you pull that in and allow the artificial intelligence and the learning models to now go pull from that information to help drive better decisions? And so as we have built these applications, we are continuously innovating. And so in the last year, this is just a subset of some of the things that we've been releasing. Our allocation optimization application, this is an extension to some of the capabilities built on our supply chain model. We had a customer that needed this to be able to expand to solve an adjacent problem to theirs. And so it was very quick to be able to go into this adjacent space for us because of the way the platform was there and the data was already available. Our enhanced scenario planning, what Soumyo is going to show you in our production schedule optimization. Imagine the ability to do what-if scenarios and be able to test different theories out all in a safe sandbox environment. And that's what you're going to start to be able to see. And then one of the other ideas is similar parts. How do you start to see, hey, maybe your data is not perfect. I mean, maybe some of you, maybe one of you has perfect data, but many of you have imperfect data. How do you know whether you're buying the same thing and it's just called something different? And being able to pull that information together, being able to say, hey, these are really the same thing. Let's now go analyze them in a group. That starts to become a future capability that we've just started working on and getting released. And then what's coming? So in our roadmap, where we're working on, is now some of our demand realignment. So the ability to say, hey, I don't always have all the data that I need in order to do a forecast. What if it's a new product? What if it's an end-of-life product? How do I start to fill in those gaps? How do I start to bring in this information and align those demand signals so I can now be able to forecast and create those forecasts that are now improved, along with then the visualization and the ability to now be able to see this information and be able to come up with a more accurate forecast when I'm lacking it by learning from the other information that's associated. For our inventory optimization, we're using multi-level bill of materials. So we have been traditionally working on what we call our single echelon capability. Now we're starting to expand out into that multiple layers in a BOM. Be able to say not just the question of how much should you stock, but now where should you stock? And being able to help you with those strategic decisions that go into the supply chain, not just the tactical of the how much side. And then our advanced alerting. This is going across multiple applications, but how do we now start to get the AI and the systems to say, hey, this is where you need to focus your attention even more. Here's now why you need to focus on that. And now let's go into the evidence package and then go start to take action. And so you'll start to see some of that coming in. And then as you heard, we are investing heavily as a company in our agentic AI workflows. And so when we start to design these and look at what does this look like in the supply chain? And so in inventory optimization, it could be, how do I go through and have the agentic AI start to tell me what do I need to see in order to build trust in this model? How do I now step through the process, be able to create specific groups that are now saying, hey, all of these groups are now impacted by this same event. Do you want to go process them and make your team more efficient by working on those recommendations together? Along with then, here's the information that you need that is specific to that particular group. In our production schedule optimization, that could be, hey, I've got a new alert. Now, what do I need to do about that alert? How do I now switch and have the agentic AI take me through the process of running a new scenario, testing out new capabilities, and having it already done ahead of time so that now I can go see what's possible, and it's helping guiding me through this so that when I show up in the morning and I see that there's an immediate problem, now I have a plan right away at the beginning of my day, and I don't have to wait for something to go process. The agents can now help me step through those different processes. And then another opportunity that we are working on in these designs is, in demand forecasting. So much of the demand forecast is that change management. How do I build the trust that this forecast is accurate and that it's telling me the right numbers? And so, yes, we can feed you a whole bunch of inputs. Yes, we can show you all the data that went into the models and show you what all the contributions are. That's in the application today. But now how do you start to describe this? How do you start to have it explain in natural language, this is what's happening, this is why you need to pay attention to this, and this is what you need to do about it from an action standpoint. And so the goal of how we're going to start using agentic AI is really to start to make the users more efficient, guide them through these processes. Those are all workflows that exist today. But how do we now take this from that choose your own adventure to actually have this guided experience? And that's where we start to see in our applications this starting to take effect.
Hello, everyone. Is everyone excited to try out some software? Right. I think we have about 30 minutes while I still have your caffeine levels and sugar levels in check. We're going to do this. We're going to try out production scheduling optimization today. Yeah. This is one of the applications in the supply chain suite, which Justin just spoke about. Why did we choose PSO? Just because it's our favorite. It's meant to be for production schedulers. Now, just quick show of hands. Is anybody here already familiar with C3 AI PSO? No? Perfect. Then that's exactly the sort of people we wanted in the room. Very quickly. So what is PSO about? PSO is for schedulers, right? Schedulers who actually decide what gets produced in a plant at what time. Right? These are usually the last in the chain of planners. And usually, they consider themselves the most hardcore of all planners because they're right before execution. They have a tough job, usually, because you have shared resources, which could be production lines, they could be workstations, they could even be labor. And you have a lot of different customer orders or production needs, which you need to meet with those shared resources. If you get the mapping wrong, or if you get the scheduling wrong, chances are you're producing things too early and producing some things too late, or producing things which don't actually have their materials ready for them yet. And all of these lead to, obviously, bad consequences for the supply chain. Okay. Now, C3 AI PSO, we designed this knowing that the scheduler's job in every company is very different. Right? Even the shape of the data, information, constraints, objectives can look very different. And that's why we've build this application to be as extensible, as customizable as possible. Right? So just like Justin mentioned, we get a lot of data in, and that could be from your ERP traditionally. It could be from your MES. Of course, we need forecasts. We need what's your existing orders. We can even take in information about your production lines, how much do they produce, at what rate for each item. And we can even bring in some external data feeds. For example, weather, which might be important for companies which do outdoor workstation monitoring, and you can't really lay out concrete when it's raining really hard, for example. Right? All of this is really benefited from the platform. So I know we've been speaking about it in generic terms, but why does it help PSO? Firstly, we can integrate a lot of data into the platform and make it abstracted for the data scientists who are going to finally build the optimization module. Right? Data scientists love using C3 PSO because C3 Optim and C3 Optim Flow are proprietary technologies which data scientists can use to manage different optimization models. It's like the KRAS of optimization models. And of course, infrastructure as a service is super important, and the fact that platform allows you to scale up compute is super important for PSO because optimization requires a lot of compute power when done correctly. And the platform helps scale up your hardware requirements as required. Okay. So this is what we're going to do. We're going to all pretend that we are schedulers at Acme, of course. What does Acme make? It makes audio systems for cars. Right? And we have a bunch of facilities. We assemble electronic components, speakers, and assemble them together into finished audio systems for vehicles. Why is production scheduling hard? Well, because demand is high. And our factories, our production units are being pushed to their limits. and we're at the risk of not meeting customer orders. Right? So for the next 5 minutes, I just want to make sure, show of hands if you have a browser open on the laptop in front of you. Right? And if you don't already have PSO open, please click on the bookmark. It should say C3I PSO on the top left. Right? There's an extra laptop here as well, if you like. Right. You also have a set of handouts like these on your desk, and please raise your hand if you're not able to follow along, if I lose you. But before we begin, quick reminder of what's already happened before you log into the application, right? So we've already ingested a lot of data from your ERP systems and your MES systems into the software, and that will be reflected here. You have material masters, your bills of material, every single sales order you have out there, demand forecasts, and even your MRP parameters like safety stocks, et cetera, that you want to maintain. Okay. So now let's move to software. Once you click PSO, you should see something like this. I'll quickly refresh to make sure. All right. So this is a landing page just because PSO can be configured for multiple production sites at once, and Acme has these 5 sites, right? Today, we'll all pretend that we're the schedulers for Atlanta. So I'd like you to click Atlanta scope, where it says the main schedule. Right. And you should see something like this. Now, those of you familiar with scheduling in general, you'll recognize this is a Gantt chart, right? And a Gantt chart is primarily a way of visualizing what your schedule looks like today across multiple work streams. Here, because Acme is manufacturing speakers, what you see on the left is the resources, which are essentially production lines or workstations. So here we have 2 lines which are meant for final assembly, right? The 2 workstations which are meant for final assembly. The next 4, which say SMT and TTH, are typically used for putting together electrical components. So the SMT ones are going to be used for making the head units. TTH are going to be used for putting together amplifiers. Those are put together with the speakers in sub-assemblies, and then finally it goes to the final assembly for making the finished product. Right? On the x-axis over here, you have time. And in this case, we're doing pretty granular scheduling because each workstation is making multiple orders on the same day. So starting from the morning, you have a bunch of production scheduled. The length of each of these bars represents how long that particular production run is expected to take. And that's obviously proportional to how many you're going to produce, and it's inversely proportional to your productivity. And all that information is already fed into the C3 IPSO application. Right? Is everyone with me so far? Yeah. All right. So I know that a schedule exists, right? And it looks OK. But my big question is it good enough? Am I going to meet all my customer orders if I follow this schedule and don't make any change? So for the next couple of minutes, we'll just try to get an answer to that. If you're happy with the way the schedule looks, great. We all go home. Right? And the way we're going to check is clicking on position report here on the left. So I'd like you to click position report. And wait for this chart to open. What we call position report is essentially a way for you to quickly analyze whether this schedule is going to get the job done. Right? And here at Acme, the one thing which I'm really insecure about is missing customer orders. And the way I'd look at it in PSO is the supply shortage number down there. So if you can see, one of the metrics here is supply shortage. And you can scroll down to see supply shortages elsewhere as well. Right? So I have at least two items, if not more, where I'm actually not meeting my customer demand between now and the end of the week. Right? Now, here, quick side note. This is a discrete manufacturing situation because we're manufacturing audio equipment. But the same concepts apply for a lot of different industries. So PSO has been configured for a steel mill, for example, where you're running a continuous caster operation. Right? Very different look, but very similar in terms of concepts of shared resources. In one of the steel companies that we work with, they make a lot of made-to-order parts. Right? So you're not really making to stock. You're not keeping stock of a bunch of SKUs which you need to make sure the shelves are full of. you want to make sure you produce the custom item that the customer has asked for and make that in time. So here, the position report for those cases looks very different. You're not going to look at SKUs over time. You're going to look at a customer order and figure out whether you're making it on time or you're going to be late. Right? In another situation, very different, was an agricultural producer. Right? And in that case, we are scheduling the teams or crews of harvesters which are going to go from field to field. In that case, again, we won't be looking at items. We'll be looking at fields and their status with respect to where you wanted those fields to be, whether ripener should have been sprayed or not, whether it should be ready for harvesting or not, whether it should already have been harvested or not. And this view gives us a sense of whether this schedule is doing my job. So now looking at this and looking at all the red stuff over there, I'm obviously a little scared. Right? This schedule is not working. It's probably because I had not forecasted correctly, or my previous schedules weren't followed to the hilt, and which is why right now we're in trouble with a few of these items and orders. Right? Now, the next step is, what do we do about it? Right? So any ideas on the table here in terms of what we would do if we're running so short on critical items? Creative ideas? None? Push out orders, that's one idea. Any others? Reallocate work. Yep. All hard choices, right? Pushing out orders means that customers don't get it when they were expecting it, and someone will have to call up the customer and say, sorry, you're going to get it a week late, right? Maybe I have an LD clause on me, which prevents me from doing that. Or expedited. Now, I'm actually a pretty traditional guy. I don't have very creative ideas. My solution usually is, let's throw people and time at the problem, right? Let's make everybody work overtime hours and fix it. And at the lack of other ideas, that's what I want to go with. But can I be confident about that idea? Not really. What if the constraint is not that we don't have enough people and time? What if it's materials? What if it's that all my systems are down, and that's why even if I ask people to stay over till dinner, I won't get it done? And the only way I can answer that is to actually simulate what would happen if I were to ask everyone to stay back. So that's what we're going to do next, right? We're going to create a what-if scenario on what would happen over the next week if I ask everybody to stay over till dinner. And for that, I'd want you to click Create New Scenario. Just name it after yourself so you can recognize it later. Let's start from today and run for a week. Yeah, so March 19th to 26th, and hit confirm. Right. Now, this will take a while. What it's actually doing is it's setting up a sandbox for you, right? It's setting up this environment where you can play around, test your schedules, run an optimizer, all without affecting anybody's work, because you're not actually changing what the master schedule looks like. You'll only change the master schedule once you're confident about your answer, right? So that sandbox will be created. You'll see a little banner telling you that it's ready. And when you click this drop down over here, you can see yourself on it, and you can click that. Okay. So I'll wait for everyone to catch up.
But the issue wasn't the supply of the material, right?
In this case, actually, I don't know yet, right?
But there is, supply shortage. That's the issue.
OK, so supply shortage here means that I'm not supplying enough. So this particular SKU doesn't have enough supply from Acme. So I don't have enough on my shelves. That could be a production problem, or it could be a raw material unavailability problem. But we don't know that yet.
Supply to your customers.
Supply to my customers, correct, yes. Yeah. All right, just quick show of hands. Does everybody have a green bar at the top of your screens? Right, awesome. OK, so now let's try and get everybody to stay till later, right? So what we do is we're going to change the working hours of our plant. So we go to facility capacity. Right? And in facility capacity, I have a bunch of calendars already set up, which I typically use for my production scheduling. So typically, everybody has an ABC shift.
A lot of people are not following how to create a sandbox.
How to create the sandbox? OK, let's go back a bit. Right. A couple of seconds ago, we were here, right? This is what we call the master schedule. This is where you're just reviewing the current schedule, but you can't make changes to it, right? That's when you have the blue bar on top. There's a button on the right over here saying create new scenario, that's what we need to click. Right? When we create new scenario, you'll have a little pop-up in which you just want to give it a name and choose dates. And 19 to 26th is a good combination, and you hit confirm. Right? When you hit confirm, you need to give the application a couple of seconds. You'll get a banner which tells you that a scenario is being created, and a few seconds later, it'll tell you that it's done. And when it's done, you'll be able to see your scenario in this dropdown. Okay. All right. So what we're going to do now is we're going to change the schedule of the factory for the next 1 week. We're going to call everybody up, say, guys, it's crunch time. We're in a peak period. We all got to do some overtime here. So what we're going to do is instead of going home at 5 p.m., which is my usual schedule, a 2-shift schedule, we're going to run in 3 shifts. And that's called an extended day for me. And I already have a preset template for this. So I can click this little edit button on the right and increase its priority so that it's actually chosen over the other schedules. Right? And we will do this for the next 1 week. So let's just do 19th through the 26th and hit adjust. Right? So what's changed now is that my factory schedule looks a little different. We have a regular day, 19th, because that's today. From tomorrow onwards, we're going to be on an extended day schedule for the next 1 week. And then we're going to head back to our regular schedule. Right? So it basically means we're going to pump up the number of people in our plants and how long they stay. Right? Okay. Another thing I can do is push out all my downtimes. Now, manufacturing excellence said we should take a downtime for 1 hour to clean up our workstations every day. Right? And that might be best practice, but now is not the time for best practices. Now is the time for production. So for now, I'm going to kill my downtimes for the next 1 week so that we keep producing during that time. Right? So I can just, again, hit delete and delete a couple of more. Okay. And at this point, I've significantly changed my production calendar. Right? Quick show of hands. Are people with me? I know this is a slightly complex workflow. Has been done based on heuristics. Heuristics being, let's take our top important products, let's schedule them first. Let's occupy the mornings with them. And then if we have time left, we'll do product number 2, product number 3, et cetera. Right? That's heuristics. It works well enough in simple situations where you don't have a lot of supply chain complexity, where your demand and supply are fairly steady and you can live life on autopilot. But you miss out on situations where you have soft constraints, which heuristics typically don't do really well with. And you miss out on situations where your current state is not similar to what happened yesterday and day before. Right? In those cases, you want to use a proper advanced ML optimization model to find what would be the global optimum for you and find situations where you could have just moved a few production orders around and met all your demand. That's what's happening here in the back end. It takes time. It inconveniences a lot of electrons inside CPUs and GPUs, but it gets the job done better, and it's objectively more performant. In our recent customers, we've seen a benefit over heuristics of about, like, say, a 2% on time in full rate, which is huge when you're already at 95 going up to 97. That's a huge big. Reducing changeovers or reducing yield losses by 1 to 2%. And we've even had cases of increasing throughput by resolving material imbalances by 6 to 10%. Right? And for customers who need these sort of changes in the supply chain metrics, this is a huge deal. And that's how much of a delta you get from running an optimizer as opposed to just doing heuristics. Right? And right now, also another thing, we just changed facility calendars because I wasn't very creative about what we can do. But a lot of our customers have actually been a lot more creative. In the case of a food manufacturer, we changed not just working hours, but how much is their safety stocks levels. Dwell and bloom constraints, when stuff needs to just sit there for a while for quality checks. We even had a case where they make kosher food, so you can only make it at a time when the rabbi is in the plant, to certify the kosher food, we could put that in as well, or change the schedule of that. In steel, we looked at the transport schedules of barges, and what is the current product which was run on the line last, because that impacts changeovers. In a CPG company, they typically had a soft constraint around the speed at which you run a line. When you run at 300 tons per hour, you have fewer quality defects, but when crunch time comes, you can push it up to 400, and you could change that here and try a scenario with those. So let's head back to our application. We should be done with optimizing, and we're going to go back to our position report and see if it worked. Right? And we go back to position report and hit this refresh button on the top right. And it's going to recalculate your projected inventories, how much you plan to produce now that you have more working hours in your day. And it's actually moved around all my scheduled orders. So if there was an order for item A tomorrow, but item A is not really short, it would have replaced it with an item B and done all those optimizations, would have tried out a bunch of permutations and combinations. Now let's look at this again. If you remember, we had a shortage for this first product and the second product in the middle of the week. It's gotten rid of most of that. Right? The third product as well, no shortages anymore. We are only left with a shortage for today for one item, because I'm guessing we just don't have time left today. But for the rest of the week, up till the 26th of March, we're actually sorted. Yeah? So that's going to take care of our shortages for this week, largely. And next week, we're going to have shortages again, right? Which means that we couldn't produce a lot or enough to meet next week's needs. And we'll probably need to stay overtime next week as well, unless we have better ideas. Right? So at this point, am I convinced that this is the right thing to do for the company? Yes. We got rid of our shortages. We're meeting our customer demand on time for this week, and that was super important to me. So we will accept this. And now that I know that running the plant overtime works, I want to share the schedule with the rest of my company and make sure that the operators know what they need to produce and when. And this is when I will go and promote. So here you have options of just promoting your schedule edits, which is what to produce when, or you could even change the factory capacity edits that we just did right now. Yeah. Since we have a few minutes, I will talk about variant, which I was going to skip in the favor of time. Variants are our way of managing different objective functions. Now, as a scheduler, I might actually be solving for different things on different days. What do I mean by that? In my lean season, I'd want to make sure that quality defects are as close to zero as possible. I follow all my best practices around cleaning my lines or scheduling downtime to clean my lines. And that's OK when you're in a lean period and you have excess capacity. You might want to give up on those on days when you're actually supply crunched. So here right now, we were running with an active variant for improving flexibility and resilience, which gives bonus points for being able to shut down your lines for an hour or two. But what I would have liked to use during this time is ensure on-time delivery, right? So if I click this, I'm essentially changing the objective function that I want my optimizer to solve for. And now it might give rise to a little more quality defects. It might run your plants at a slightly higher rate, but we want to make sure we deliver all products on time. It might come at the cost of throughput, because I will take more changeovers to meet my customer demands on time, and changeovers cost time, but if that's the reality of life, so be it, and I want my optimizer to choose for that. So it's very flexible. We have schedulers usually set up multiple objective functions for this reason, because they know where their plants or the business are at any given point of time. Right. And with this, we hit promote. I'd like you not to promote right now, because all of you are actually on the same shared environment, so you'd be changing schedules for everybody else in the room. But I will take a pause right now for any quick questions before proceeding.
I'll go first.
Mm-hmm. Yep. Actually, no, but you're projecting pretty well, Francesco.
Can you hear me? Okay, anyway, I'll talk. So what is not clear to me, and sorry about that, is it What is the goal of the objective function of the optimization? Is it only to the customer satisfaction, the availability of, can you change it and use a combination of customer satisfaction, production efficiency, inventory cost? Can you define any kind of goal?
Absolutely, yes. So one thing we typically really encourage every customer to do on day one of deploying PSO is deciding what do you want to solve for, right? And we really work hard on this. So I would ask you, what is the key metrics? And you need to break it down to me in metrics. And if there are multiple metrics, you need to give me a weighting between the two. So for example, if OTIF is super important to you, great. But then you also tell me that throughput is important, like how many tons per day I produce. And if you're a steel mill, those two don't really go well together, because every single time you change the chemistry or the grade of steel you're making, you need to swap out a bunch of things. You need to drain out whatever metal you have, et cetera. It costs money. So I typically ask you, if it's OTIF and throughput, what are your weights for each? If you can convert both into dollars, that's great, right? And if you can convert everything into a dollar cost, the objective function is the sum of all those costs minimized.
Is there the possibility to look at investment planning? So for example, typically on manufacturing lines, there might be some constraint, like I can only handle 1 liter bottles here on this line, and on the next line I can handle 5 gallons. But if I invest, I can change the manufacturing profile.
Let's look at that a bit over here. So great question, right? What the question was, can we put in constraints that we might have, which are typically not even there in the ERPs, which is I can only run SKU A, B, and C in lines 1 and 2. I can run B, C, and D in lines 2 and 3, but I can't run SKU D in line 1 and so on. We do ingest all this data from your MES or your ERP, wherever it's stored, or we can even maintain this information in C3 IPSO as a system of record if you'd like. And that's typically done in this whole section called master data, which I didn't take you through because it's a gory level of detail, but let's look at it right now. So over here, we have information for every SKU in every facility and master data for that. We have something called the changeovers grid, which contains the information that you have, right? So every constraint over here tells you what material I can produce on which line. And if I move from material A to material B on a line, what do I lose in terms of time or money? Right? For example, in the steel case, if you run from one chemistry which is high in vanadium and copper to another chemistry which is low in vanadium copper, you actually lose about 30 tons of material which was there in that physical ton dish that kept all that molten material, right? So that costs you money. If you could have produced a few more bars of that, then you could have used that up, for example. In the case of an ice cream plant, you can't run vanilla right after you run chocolate until you run a thorough cleaning cycle. But you can run chocolate after you run vanilla, it's okay, right? And that costs time and money in terms of cleaning, right? So all of that information can be fed in and used by the optimizer to keep it in mind. We also have other stuff like transportation lanes. So how much does it cost, or how much time does it take to go from one facility to another facility in terms of transit time? We even have safety stocks and max stocks, and you can set up your own shifts, and you can choose what recipes or which alternative bills of material you want to use. So there's a lot of complexity here. All of that is in master data, and the application is designed to take all of that in a modular fashion. Not everything will be relevant for every customer, but as general concepts, they all exist.
I think we have time for one more question.
Mm-hmm.
Do you already have in the base application complex scenarios like batching of operations, like for coating or putting hold point because maybe you need customer on site, or I don't know, like waiting time because there's drying after painting,
Yes.
or, so all these kind of manipulations, because
Yes.
scheduling is quite complex in the manufacturing environment.
Exactly. And that's why you'll notice that every single PSO deployment does actually involve a unique optimization function and a unique optimization formulation, right? So for example, dwell times, bloom times is what you referred to essentially, waiting for paint to dry, for example, that is fed in over here as a sequence of operations. So on the Gantt chart, for example, and this particular example doesn't have it, but we can track lineage, which says step number 1 has to happen on line A, followed by step number B. Step B has to start 45 minutes after step A is done. And that's why there has to be a gap of that much. Or step A and B have to happen in parallel at the same time so that they end at the same time. So we have all of these constraints put in, where you can define the order of operations and have a start-start condition or a start-end condition or an end-end condition. Sorry. I would expect meeting invites not to pop up. Yep. If we have a couple of minutes here, I just want to go back to the rest of your time at Transform and also about the rest of the supply chain suite. So what you saw here was a point solution, just deploying PSO at one customer for the problem of production scheduling. That's possible with C3 because all of our applications are like Lego blocks or Lego sets. You can buy one at a time and try it out and have fun with it and see if it adds value, great. But getting one also means that you actually unlock the door for more Lego sets, and everything is compatible with everything, right? So in this case, if you've done production scheduling optimization, you've already ingested most of the information you need for demand forecasting and inventory optimization, right? And you've ingested about half the information you need for sourcing optimization. So strongly recommend starting off with one use case, expanding to others, or go big bang and start with all if you'd like. And we're right at time. Thank you so much, everybody, for being here late afternoon, right before dinner.